Okay, this is 2.6 in your textbook, page 119. We're looking at simplifying polynomial expressions. Who can remind me, please, what a polynomial expression is? Matthew, nice and loud.
It's when there's like multiple, it's like when there's multiple algebraic expressions.
No, not multiple algebraic expressions. Those would be like different equations. You're close, Jesse.
Two or more terms.
Two or more terms within one algebraic expression. Okay? So that's going to be a great communication question for the test. Hint, hint. What's a polynomial? What's a binomial? What's a trinomial? And in your own words, Noah, again, what's a trinomial?
Algebraic expression with three terms.
Excellent. Perfect. Okay, so we're simplifying polynomial expressions. So we're taking an expression with two or more terms and we're simplifying it down. Okay, so we're gathering like terms basically. The first question reads, who'd like to read on page 119? Would you like to pick someone? Alright, Daniel, 119. Let's start with Todd.
Todd has a landscaping business. He employs 4 truck drivers, 3 assistants, and 15 student laborers. The pay structure for the business is shown below.
Okay, you can skip that. That's on the board. Yeah, keep going. Todd wants.
Todd wants to use a spreadsheet to determine his weekly payroll. He assumes that in any one week, all of the employees will work the same number of hours, but also that the number of hours they work from week to week will vary.
Okay, good. So we have this table here. It tells us the type of employee, the number of hours that they work per week, and then what they actually get paid. Okay, we're looking to take this information and create an equation where we can vary the amount of hours per week and plug it into our spreadsheet and figure out the answer right away. Okay, so there's two things we want to assume. We want to assume in any one week that they're all working the same amount of hours. Okay. Sorry, this is not the number of hours, this is the number of actual employees. So there's 1 owner, 4 truck drivers, 3 assistants, and 15 student laborers. So they're all working the same amount of hours per week. And also from week to week, the hours will vary. So because of the fact that the hours will vary, that's a good indication that we'd want to use a variable for the hours. And what is a variable? Tell me what a variable is. I say that word a lot. If you don't know what it is, it could be confusing. Marnier?
It's a number that you use, it's a number that you substitute within.
Yeah, and what do we usually use on the board?
Algebraic expressions.
No, for a variable we use a,
Letter.
not a number, but a
Ladder.
letter. We use a letter, any letter. Typically we use X, right? And then we use Y, but in this case we're going to use H because we're talking about hours, okay? So when we talk about what a variable is, we're talking about basically a letter that we can use to represent different numbers, okay, depending on how many hours. So we want to create an equation where we get the total payroll. So we want to know the total cost of all of these factors. So if I want to create an equation just for the owner, all right, he makes $800 a week. And it doesn't matter how many hours he works. What do you think the total or the number I would put in here? It's not variable, right? It's just 800. Yeah? Yeah, just 800, right? There's nothing that changes, okay? Because he makes 800 per week, every week. So Kevin, if I want to put in an equation or an algebraic expression for the truck drivers now, they make $17 an hour plus 150. How would you write that?
4 brackets 17 8 plus 150.
Excellent. Perfect. That's exactly right. Okay, and what Kevin did was he said, well, there's 4 of them, so I need to multiply however much one of them makes by 4. Okay, and one of them is going to make 17 times the number of hours that they work plus $150 for gas, I think in this case. Okay, so that's a perfect equation for our truck drivers. Our assistants now, Chris?
3
Yeah.
bracket 12 times age plus 50.
Excellent. Perfect. And finally, our student laborer, Selman?
10 each.
10H. Excellent. There's no there's no fixed cost for them. So it's just a variable of 10 times 8. Yeah?
Don't you have to add the 15 times?
Sure, you're right, yeah. My bad. We could put it on this side, right? But I prefer to write it the other way. So 15. Okay, you got that right, Solomon? There's 15 of them. All right, so now we want to know what the total sum is. Well, if we want to know a sum, what do? We go.
8, 7.
So my total payroll is going to be equal to what?
All of the,
Yeah, so tell me.
it would be 800
Yeah?
plus 4 brackets 17H plus 150
Yeah.
plus 3 bracket 12H plus 50. And then plus 15 times 10H.
Okay, you want to just move the camera so that they can see that? So I've just continued the payroll down to this line. Next step, can anyone tell me what the next step might be? What do we want to do with that information now? Josh?
Calculate the sum.
Yeah, so what are we going to do? What's the next step?
Oh, so you can convert all the brackets into.
Right, we want to get rid of the brackets. So the first thing would be, if there is anything I can do in the brackets, I would do it first. There's not, because there's no like terms. Michael?
Simplify it.
Yeah, we're simplifying it, right, exactly. So we expand and simplify is what we call it. We call it expand because we're expanding these bracket terms. So we learned this in the last lesson. It's called, what is this process called? Joseph, that I'm using here. As I do it, you can tell me, what is it called? It's a certain property. You remember? It's a law. Right. It's called the distributive property. Excellent. Okay, so once I'm done, we started with a very large polynomial, and we ended up with Carlson with a very small binomial. Very good, yes. Or also a polynomial as well. You could say a very small polynomial. Remember, binomial is a type of polynomial. Okay? Any questions there? So now, with this very nice, neat little formula, I can say, well, if all my employees work 8 hours next week, or 20 hours, or 40 hours, I can plug in a 40 there for H and figure out my total cost. Okay? You see the power of this type of algebra? It's a lot easier, right, than having to go back to here and say, okay, well, he worked 8 hours, he worked 4 hours. Okay? The one big kind of caveat or exception for this particular problem is that we were assuming that they all work the same number of hours per week, which may or may not necessarily be true. Okay, but in this case it was. That allowed us to let H represent the total number of hours worked. Any questions with that first problem? All right, moving on. Next one, example 2, it just says simplify. So I'm going to use the distributive property. Distribute this 2 and distribute this 3. I don't include that middle step. I'll just do it in my head. This is 6x plus 2 plus 3x minus 12. Now we have a 6 and a 3 is 9x, and a 2 and a negative 12 is negative 10. Matthew?
For the previous question,
Yep.
what were the steps that you did to get to 254 H plus 150?
Okay, good question. So I took this H, and this H, and I added them all up. That gave me 254. Okay? And then I took this number, and this number, and I added them up to get this. Okay? It's called gathering like terms. All right? Okay, moving on. So 9x minus 10. Any questions with number 2? All right. Number 3. We're looking for this unknown variable. So the way you solve these problems, guys, they are a little strange. They're kind of a weird problem. But what you want to do is you want to simplify this expression so that it's in the same format as this. Okay, so in order to do that, we want to expand and simplify this side. Okay, we're going to leave this side alone for now. So let's do that. So 4x squared minus 3x plus 2. This negative needs to distribute to each term. So when we multiply by a negative sign, this positive x there, even though you don't really see it, there's a positive sign there, becomes negative x squared. Basically changes the sign of everything within the brackets. This is a difficult concept, believe it or not. A lot of people struggle with this idea. A lot of times they'll just erase the negatives, the brackets, and give the first one a negative x squared, but then they won't change these two signs. You need to realize that it's a negative 1 that's in front of the brackets here, even though you don't see it, and it's getting distributed to each term. So even though this looks like a negative x squared, it's a negative and then in brackets positive x squared. So this sign does change. Okay? You guys see that? Josh?
That was just minus, subtract.
Yeah, it's subtract x squared. So it would be plus a negative, which is subtract. Yeah, it's minus x squared. Okay? All right, so now we can gather like terms. You can see I'll circle all of the x squares, and I'll put a square over all of the x's. Make sure you include the sign when you're doing it this way. So we have 4x squared minus x squared is 3x squared minus 3x and plus 9 plus 6x. And then plus 2 and plus 1 is plus 3. That's the most we can do. That's the most we can simplify. So I'm going to put in the original question now, blank x squared plus 2x plus 1. So now, if we look at this and this, which is our first two terms, I'm going to say, what times x squared gives me 3x squared? And the answer, of course, Michael? Yeah.
The answer is, well, wouldn't it be?
But you can either just look at it and tell me the answer, or if you need to, we can figure this out, right? We can say, divide this by x squared. So these cancel. So you're left with just the blank box here is equal to divide this by x squared. So we're dividing by the same value. See this, Michael? That's right. Okay? Or you could have just looked at this and been like, well, 3x squared, blank x squared, well, this has got to be a 3. Right? It was pretty evident at that point, but if you want to, you can divide out and find it this way too. Okay? Pay attention, okay, Michael? Next one. This one is we're expanding and simplifying. So, Philippe, what do I do? What am I going to use?
Distributive property.
Good. Okay, so do you want to just read it out to me?
So 3x.
No? You're going to skip that middle step?
You put the
Okay, so what is it? 3 times 4?
12.
Yep.
X,
Yeah.
minus
Yep.
6
Yep.
x5.
No? A 2 and a 2?
Oh, 4 plus
Yeah.
that's 18 plus 3 x2 x3 x3.
Okay, what do I do here?
And then you put the negative sign for all.
Yeah, so I'm just going to change all these signs. Remember, the first one is positive originally. It becomes negative. This becomes negative. And this becomes positive. And the last term, I can't do anything with it, doesn't change, so I just rewrite it. Yeah, Daniel.
How come you wouldn't change the last one? The 7x.
This one? Because it's not multiplied by the -1. This -1, you're asking why I wouldn't change this sign?
Yeah.
Because it's not in the bracket, so it's not multiplied by -1.
Okay.
It's just on its own, okay? Any questions? Yeah, Matthew.
How come you didn't change the 5x to the exponent of 4 to the negative?
5x, I did, right here.
No, you didn't change the plus sign to a minus sign.
Where? Here?
Yeah, no, it's just to add
The 4x. 4x.
Here?
No, over it. No, it says to add 5x to the power of 4. Yeah.
I'm confused, Matthew.
Sir, no, at the original equation, before you did anything,
Yeah.
it says x to the exponent of 5 plus 5x to the exponent of 4.
Yeah?
Didn't you change the addition to subtraction?
This plus this to subtraction?
Yeah, didn't you change that to subtraction in the next step?
No, why? I did. So it came to negative here.
Oh, okay.
This negative x to the 5 and then negative 5x to 4. Okay? Not sure if I answered your question or not. Did I?
No, yeah.
You got it? Alright, so now what do I do next? Michael, Chetty. What do I do? You know? Are you no? Okay, listen up then, okay? Vinoshan, what do I do?
You had to like make shapes with like circle.
I don't have to do that. I don't have to. I don't want to.
Separate.
I do that over here because it was the first time, and now I want to, do it like a real man.
You separate like the ones with the 5 exponent and the 4 exponent.
Yeah, so that's called what, David?
Combining like terms.
Yes, combining like terms or gathering like terms, okay? So I'm going to take all the values that have an exponent of 5. Remember, we can't combine, remember we talked about this? If this is x squared, and this is x cubed, that's why we can't combine an x squared and an x cubed, because they're different styles of terms. Okay, they're different terms. So I need to find all the x5s. Okay, if I could draw in 5 dimensions, I would. I'd show you 5 dimensions here, but of course we can't see in 5 dimensions, so take my word for it. We're only going to combine the x's with the 5. So here I can do this in one step. I have a 12x5. Careful of the negative signs. You've got to make sure you keep that. Minus 1, so that's 11x5 plus 7. 11 plus 7.
So why is it 11?
Because it's minus x5.
Because you have 12 minus 1.
Oh, you didn't show the. Oh.
Okay? Next, I'm going to go one down. Always you want to start with the highest exponent and move your way down. Okay, that's proper form. David, what's the next one?
6x or 18x. 6x.
No, so you're going to look at x to the 4, so what's the value going to be?
6x 4, and then you're subtracting 5x 4, so that's x4.
See, so you made a mistake there. So this is going to happen, probably the most common mistake. See how you missed the negative sign? You said 6x4. That's going to be your most common mistake, believe me. It's negative 6x to the 4. Okay, minus 5x to the 4, so it's minus 11. Okay? If it helps you guys, we can rewrite it. We'll do one more step before we go without skipping steps. So here we're going to write it out. We go 12x to the 5. All I'm doing is bringing all of the same styles to the same, putting the same exponents in order. So if it helps you to write this step, by all means, you can take the extra couple seconds and just put all the 5s together, all the 4s together, and all the 3s together, and then do it. That might help you without missing negative signs. Okay, now it's a little bit easier to see. 12 minus 1 is 11, plus 7 is 18, x to the 5. Negative 6 minus 5 is negative 11. Can't add those, so I'm at negative 11, x to the 4. And then I have 18 and 18 and 4, both positive, so I have 22x to 3. Okay? You see how you missed that negative, David? So if this helps to do this step, by all means, do it. If you can just look at this and start combining without losing track of these negative signs, that's fine too. All right, last question. Can I have a volunteer to read? This is the last question. Yeah, go ahead, Janoshin. Thank you.
The sporting goods company provides skis and snowboards to instructors at ski resorts. Determine an expression that represents the combined value of equipment after Y years of use. Use this value to determine the combined value of all the equipment after 2 years of use.
All right. So, if we know that the cost is $600, but it drops $50 per year, and we want to know after 2 years, let's say, first and foremost, let's let Y represent the number of years, okay? That might be the hardest part of this problem, is just making that decision. What variable are you going to use? What is it going to represent? The number of years appreciated. Once I do that, now I can figure out my equation for the new value after 2 years. Or let's just do it after Y years. Okay, so what would the equation be for the skis? Yeah, Michael?
200
Good.
bracket 600. What was the Y?
600Y?
No, what was the
2 years.
oh, so 2.
No? You're going to minus
Oh, minus 50. I
$50
thought that was an answer.
times the numbers of years.
Oh. I
Okay?
thought that was an answer.
No. You guys understand that? So now after 1 year, you're going to multiply 50 times 1, so it'll be worth 550 times there's 200 of them. Okay? So Mark, can you try the equation for the snowboards?
300
Yep.
bracket 800
Yep.
minus 60y.
Excellent. Jesse?
Multiply that answer by 2.
Multiply this by 2? No, now we're going to sub in 2 for y.
Oh.
Okay? But it says, what is the combined value? So what do I got to do? Michael at the back. What do I got to do? How do I find the combined value of the equipment after 2 years? Yeah, you. Back. So the combined value equal to what? Yeah. No, so the combined value of the skis and the snowboards after 2 years. Can't see clearly? Okay, we might want to move you up then. Nicholas.
Add the two sums from both the equations.
Yeah, good. I'm going to add these two, right? So 200. Because it's combined, so we need to combine those two sums. Okay, now we're going to work this out. Pretty big numbers, but still relatively easy math. We simplify those, so we're going to look for the y's. Okay, so there's our combined value. And finally, the last step is you sub 2 in for y. So we get our combined value is going to be 360,000 minus 280,000 times 2. And we get 3. So finally, after 2 years, the combined value is 204. Okay? Any questions? Yeah, please?
Didn't you distribute it properly, take out 120,000?
Yes. Yes.